Hello, my name is Balasa Malandwa and I will be reflecting on the lesson plan I developed. In this reflection, I will discuss a grade 8 natural science lesson that I have designed on the topic of interactions and independence within the environment, with a specific focus on food chains and food webs in the South African savanna ecosystem. The lesson will aim to achieve three objectives. Firstly, learners will identify the roles of producers, consumers, and decomposers within the food chain. Secondly, the learners will explain how organisms depend on one another for survival within a food web. Lastly, learners will construct and analyze a food web using examples from a South African ecosystem. The lesson consists of three phases: introduction, development, and consolidation. Each phase integrates ICT to support learning, engagement, and understanding. For the introduction phase, I will use Mentimeter to conduct a word cloud activity. Learners will respond to the question, what do living things need to survive? Their responses will appear instantly on the screen and form a visual word cloud. My role as a teacher will be to facilitate the discussion, identify common themes, and connect learners' prior knowledge to the concepts of producers, consumers, and decomposers. Learners will actively contribute ideas and participate in class discussions. I classified this activity at the augmentation level of the SAMR model. The task remains a brainstorming activity. However, technology enhances the experience by providing instant visualization of learner responses and encouraging participation from all learners. Compared to the traditional show of hands discussion, Mentimeter allows every learner to contribute simultaneously and anonymously if necessary. For the development phase, learners will complete an interactive Google Forms worksheet. The worksheet will include organisms commonly found in the South African savanna ecosystem, such as grass, acacia trees, zebras, impalas, lions, vultures, and mushrooms. To encourage critical thinking, learners will also encounter organisms that do not belong in the ecosystem, such as polar bears, sharks, and penguins. As the teacher, I will guide learners through the activity, monitor their progress, and support them when necessary. Learners will classify organisms, identify feeding relationships, analyze food web scenarios, and justify their answers. They will also construct their own food webs based on the organisms I provided. I classify this activity at the modification level of the SAMR model. Technology significantly redesigns the tasks because learners interact with images, complete branching questions, receive immediate feedback, and engage in inquiry-based learning. The inclusion of irrelevant organisms requires learners to analyze information rather than simply recalling facts. This makes the activity more interactive and cognitively demanding than a traditional worksheet. For the consolidation phase, I will make use of Wayground, formerly known as quizzes. Learners will complete an interactive quiz containing multiple choice questions, image-based questions, and ecosystem scenarios based on the lesson content. My role will be to monitor learner performance using the results dashboard, and I will address misconceptions. Learners will answer questions independently, receive immediate feedback, and reflect on their understanding. I classify this activity at the redefinition level of the SAMR model. The technology enables an assessment experience that would be difficult to replicate using traditional methods. Learners receive instant feedback, they engage with gamification, and can view their progress in real time. These features increase motivation and provide valuable information about learner understanding. Throughout the lesson, both myself and the learners will have active roles. Rather than simply delivering information, I will facilitate learning experiences that encourage investigation, discussion, and critical thinking. Learners will actively construct knowledge through participation, collaboration, and problem solving. The lesson has also been designed to accommodate learners with varying learning abilities. Visual learners will benefit from images, diagrams, and food web illustrations. Reading and writing learners will engage with written explanation and responses. Learners requiring additional support will benefit from scaffolded questions, immediate feedback, and teacher guidance, whereas more advanced learners will be challenged through analytical questions, ecosystem scenarios, and justification tasks that require deeper thinking. Reflecting on the lesson, I believe that the integration of ICT tools will encourage learner engagement, participate, and understanding of ecological relationships. However, if I were to improve the lesson further, I would incorporate a collaborative digital activity such as Padlet and Jamboard, where learners would work together to create a shared food web. This would strengthen collaboration, communication, and peer learning while enhancing the level of technology integration. Overall, the lesson demonstrates how ICT can be used meaningfully to support teaching and learning while promoting critical thinking, learner engagement, and inclusivity.